So, hello guys, with the name of God, Ram Ram, we start this session, this brilliant session. This session is going to clear your many dynamic programming concepts. I have checked many courses and many YouTube videos. I see that people are teaching dynamic programming in a random manner. They are not dividing the things into the patterns. Now, this problem, maximum strength of k disjoint subarrays. This is like one of the hardest dynamic programming problems available on Leetcode. It is a hard unseen DSA question which was asked in the recent previous Leetcode contest for the last problem. Many of my students again got top 500 global ranks in this contest. Why? Because in my you guys must be knowing, I have a 800-hour DSA course for online assessment plus competitive programming plus DSA interviews, and this is the exact question, same as it is in my 29th lecture of dynamic programming in my course. So guys, what happened is that most of my students were able to solve it. Guys, this is a very nice problem which uses the partition DP concept. Partition DP concept it uses, and if we go further deep down the rabbit hole, it uses partition DP plus optimization concept. So if you apply both these concepts, then this problem gets solved. Now, how did this exact same problem come in my course also? Well, this happened because Google asked the same problem in one of their SD3 interviews a few months back. So my student told me, and I solved that problem, and it eventually found a place in my course. Also, like partition DB plus optimization now generally gets asked in online assessment, FANG online assessments. So you guys should know this concept. I will try my freaking best to explain you this in this video, even though you don't know these prerequisites. Many beginners must be watching this, right? Still, I will take that risk of explaining you this hard problem. So, guys, before going towards all of that, let's congratulate my student who recently got a world rank 50 out of 25,000 participants in Leetcode. Congratulations, Vinit Ekwani. Guys, my student Sejal, who has cracked off campus intern plus full time offer from Microsoft. My coding student Anurag Tiwari cracking Zscaler off campus. Those Zscaler asks very hard online assessment plus interview. My student Sarthak Rotagi cracking Swiggy off campus. So students are doing great. Student Karan Rana got world rank 92 in Code Chef Div 2, and Sri Raghavi, the budding coder, improving world rank 22 in Div 3. All this is happening because I'm giving them 8-month top level training for CP plus OA plus interviews. Okay, and also I provide them 800-hour course and 24/7 out support for the things inside of the course and outside of the course also. So if you are also preparing for your placements, or you want to switch, you want best level training, make sure you contact me at this number 8879 355 057. Now guys, going to our main thing, partition DP plus optimization masterclass. Rather than directly jumping to the lead code problem, let's solve this basic prerequisite question. You are given an array divided into k subarrays such that the value of g is maximum. What is g, guys? What is g? G is sum of first subarray multiplied by k plus sum of second subarray multiplied by k minus 1 plus sum of third subarray multiplied by k minus 2 plus sum of kth subarray multiplied by 1. This quantity should be maximum. So let's take an example. 543 minus 1 1. Okay, guys, 543 minus 1 and 1, you have to divide this array into two subarrays k equal to 2. So there are many ways to divide it into two parts, right? Let's choose this part. I take this part as the first part. I take this part as the second part. In that case, what will be the value of my g? First part is 5 plus 4, 9. Second part is 3 minus 1 plus 1, which is 0, so 3. The first part I have to multiply it with the k equal to 2, and this number will keep on decreasing. First part you multiply with k, second, see, first part you multiply with k, second part sum you multiply with k minus 1, k minus 2 still 1. Okay, so guys, if you divide like this, what will be the value of g? It will be 18 plus 3. 18 plus 3, which is coming out as 21. But guys, we have to maximize the g. Is there any other way you can divide this array into two parts, k equal to two parts, such that the g becomes even more? Let's like a detective Conan. Let's think about it. What if I make this as my first part and this as my second part? 543 as my first part and minus 1 1 as the second part. 543 as the first part. Then what will be the sum of the first part? 5 plus 4 9, 9 plus 3 12. Sum of the second part minus 1 1 plus 1 is 0. First part I will multiply with 2 and the second part I multiply it with 1. You know na, first part with k, second part with k minus 1. So 12 into 2 plus 0 into 1 is 24. Guys, this is bigger than 21. So this is the best partition possible in this problem. Okay, you can try other partitions also, but they are not going to give that result. Like if you try to take 5 4 3 minus 1 here and 1 in this part, so what is the sum of this? 5 plus 4 9 3 12 minus 1 is 11. 11 into 2 22 plus 1 into 2 23 24. So again it is giving 24. So 24 is the best answer for this problem. Okay, lovely people, 24 is the best answer for this problem. So guys, you guys understand these things, right? Guys, I hope you understood the question ki you will be given an array, you have to divide it into k parts. This is the array. Suppose someone says k equal to 5. So you have to find a partition like this is, let's say this is the first part, second part, any random arbitrary parts, third part, fourth part, and fifth part. So you have to divide it into 5 parts, k1, k2, k3, k4, k5. Each parts, whatever is the sum, you multiply the first part with k, second part with k minus 1, this part with k minus 2, and till the last part multiplied with 1. There are only k parts now, so this k will become 1. Whatever is the summation of all these multiplications, that value g should be as large as possible. So guys, you should either watch my initial DP lectures, so you know how to solve, like get a little bit idea about dynamic programming. Guys, we will define a dynamic programming DPI of j. What is the meaning of DPI of j, guys? What is the meaning of DPI of j? DPI of j means best value of g you can get by dividing the elements from 1 to I into j parts. So simple, so simple, so simple. DPI of j is nothing but what? So easy, man, so easy. DPI of j means best value you can get by dividing the first I elements into j parts. So let me analyze some. Let's say you are given a very big array and you want to divide these numbers in 5 parts. Okay, guys, lovely people, 5 parts. Okay, so let's say this is like this: 5 minus 1 4 3 2 1, something like that. Okay, it is like very big array, something like that. Okay, now let's use the zero based indexing here. Okay, index 0, index 1, index 2, index 3, 4, 5, 6, 7, and 8. So guys, if someone asks you what is the value of dp2 of 1, dp2 of 1 means divide this much part, the elements till index 2 in just one part. So you have to select all the numbers. So guys, what will be dp2 of 1? dp2 of 1 means all the elements from 0 to 2 index, divide them in one part. So you put all of them in one part. So answer will be 5 minus 1 4, 4 plus 4 8. 8 multiplied by k, guys. What is the k value? This is the first part na. So k8 into 5 40. So dp2 of 1 will be 40. Similarly guys, I hope you can imagine what will be dp3 of 1. Guys, what will be dp3 of 1? Basically, you can calculate the dpi of 1 very easily. It is nothing but the sum of the first I numbers. इफ आई आस्क यू dp3 of 1, इसका मतलब मालूम है क्या है? इसका मतलब ये है कि सारे एलिमेंट्स को आप ले लो 0 से लेके 3 तक, और इन सबका सम निकाल दो, यही आपका पहला पार्ट है. सो dp3 of 1 मीन्स take all the elements from 0 to 3 and divide them in one part. One part means all the numbers. So 5, -1, 4, and 3. Whatever is the sum, you will have to multiply the sum with 5 because this is the first part. Okay. So guys, I hope even though we have not calculated the transitions and everything, you guys must have understood that in dpij, what will be the value of dpi of 1, guys? Lovely people, lovely people, lovely people. dpi of 1 is always what? Sum of all the numbers from index 0 to I multiply by k. So this is very easy. Now you run a for loop. For each index I, you can maintain what is the sum of the numbers from 0 to I multiplied by k. So dpi of 1 you have calculated. For each index I, you are able to calculate dpi of 1. The thing is, we should dpi of 1 mission has been accomplished. But guys, we don't know how to calculate dpi of 2, dpi of 3, dpi of 4, 5, 6, 7, 8, 9, ultimately till k. You know, now you know how to divide the elements from 0 to I in one part. वो तो कोई भी कर सकता है. वन पार्ट में डिवाइड करना है तो कुछ करना ही नहीं है, सबको ले लो, सम कर दो, k से मल्टीप्लाई कर दो. Let's learn how to divide it into two parts. dp2 of 2. Now guys, in this case, you only use your brain and tell me, how would you divide it into two parts, lovely people? How would you divide it into two parts? You can do this. You can like take this part and take this part. So guys, first part will be 5 minus 1. Second part will be 4. First part you have to multiply with 5, right? K value. And the second part with k minus 1, 4. So answer will be 5 minus 1, 4. 4 into 5, 20. Plus 4 into 4, 16. So 36. We could also do like this. Now let's make 5 our first part and 4 minus 1 is our second part. Then what would happen? 5 as first part and minus 1 plus 4 second part. So 5 into 5, 25, plus 4 minus 1, 3. 3 into 4, 12. So 25 plus 12, 5 plus 2, 7, 2 plus 1, 3, 37. So guys, dp2 of 2 is 37. There were two options, 36 and 37. 37 gives you the best answer. So guys, I hope you understood that dp2 of 2 means find all the way, like find the best value sum g such that you can divide the numbers from 0 to 2 in two parts. Okay. So guys, now how do we find this formula? That is important. I always use this trick for my students whenever solving a DB problem. Imagine a very big array like this, okay? You are standing at an index I, okay? You are standing at an index I. You want to find, guys, dpi of j. You want to find dpi of j. So what will you do? Very, very simple. Guys, this video can take long because I have to explain many concepts here, okay? So please pardon and listen to me. dpi of j, it means you have to divide all the numbers from index 0 to index I into j part. The partition dp concept says you just fix the last part. You just fix the last part. So guys, I can say now that this is my jth part. I can say that this element is my jth part. This is my jth part, j part. Rest all of them, rest all of them are the elements which are in from 0 to j minus 1 part. Okay, बेसिकली मैं ये कह रहा हूँ कि जो लास्ट का एलिमेंट है ना उसको मैं जे वाले सब एरे में डाल दिया, बाकी सारे एलिमेंट्स 0 से j माइनस 1 वाले सब एरे में. ओके, क्लियर गाइज? 1 to j minus 1 सब एरे. Basically from 0 to I, if you put the ith element in your j sub array, then what will be the answer? Answer will be this I, right? B of I multiplied by some value y. You have to multiply it with some value, na? multiply it with some value, okay, plus 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 whatever is the best answer to divide 0 to I minus 1 in j minus 1 parts. So guys, what is the best answer to divide 0 to I minus 1 in j minus 1 part? It is nothing but dpi minus 1 j minus 1 ha ha ha, which you have previously calculated. So guys, you get the formula. dpij is nothing but the current element into y. We will find out with which number we have to multiply it, plus whatever was the best answer for the previous part. Best answer to divide the numbers from 0 to I minus 1 in j minus 1 parts. If you divide the numbers from 0 to I minus 1 in j minus 1 part, then you can say that this is the jth part. So guys, this is one of the formula of dpij. If you want a visualization, I will show it to you. 0, 1, 2, 3, 4, 5, 6. Let's say someone is asking you dp6 of 3. dp6 of 3 is nothing but whatever is the element at 6. uh let's say you had to divide everything in, let's say you had to divide everything in 4 parts, okay. So the b of 6, first part will be multi c. If k is 4, then first part will be multiplied with 4, second part will be multiplied with 3, and third part will be multiplied with 2, right? So what is the best answer to divide this array? Divide this array such that it gets divided into 3 parts. You can say that this is my third part. You can say that this is your third part. So the sum of the third part will be b of 6 into 2 plus dp of phi of 2. This means that you have divided the numbers from 0 to 5 into 2 parts. Let's say you divided imaginarily here. So one part, two part, and this third number which you made. So I hope you understood the formula. So dpij, what is one of the options? dpij is nothing but the last number you put it in the jth subarray, you multiply it by y is unknown, you have to calculate that, plus dp I minus 1, all the elements from 0 to I minus 1, you divide them into j minus 1 part. Or guys, there is one more option. Currently we are taking only the last element in the jth part now, but there can be more than 2 elements in the last part also. So guys, there are multiple possibilities. If you are at index I, you want to find dpi of j. Either you can say that this is in my jth part subarray, the last element is in the jth part, but it can also be possible na, that you take the last two numbers in the jth part, or last three numbers in the j part, or last four numbers in the j part. In that case, guys, what you will do, sum of the numbers from b of j minus 1, you have to take the sum of the numbers from b of j minus 1 till b of j, basically last two numbers, plus dp of I minus 2j minus 1, okay. So that's it guys, that's it, okay. So simple, so simple. क्या क्या ऑप्शन है आपके पास, इधर भी मैं आपको दिखा देता हूँ. dp6 of 3, either you can do b of 6 into 2 plus this, or you can do b of 5 plus b of 6. You can say that both these elements are in my last part. If both these elements are in your last part, then you just have to divide from 0 to 4 into 2 parts. So formula will change into what? Another formula will be b of 6 plus b of 5 multiplied by 2 plus dp52 नहीं आएगा इस बार dp42 आएगा. क्यों? क्योंकि अभी बस हमको 0 से 4 वाले जो लोग हैं उनको दो पार्ट में डिवाइड करना है. लास्ट के दो एलिमेंट्स तो मैंने ऑलरेडी थर्ड पार्ट में डाल दिए. सो गाइज, द मेन थिंग इज दैट इन दिस फॉर्मूला इट मीन्स last element is in the jth part. So partition dp means you fix the last part, and the further part is dependent on the old dp formula, or the last element, last two elements in the jth part. But guys, there can be many possibilities, right? You can take last three elements also in the jth part. Now you can do this till the start. Okay. In that case, you have to divide the things from 0 to I minus 3 into j minus 1 parts. Okay. Last three elements in the jth part. Okay. Guys, there are so many options. You will keep on doing this. You will keep on doing this. Okay. You can keep on doing this non-stop. Okay. Like till the start you can do this. या तो तुम लास्ट में एक एलिमेंट ले लो, और यू टेक टू एलिमेंट्स इन दिस लास्ट पार्ट, थ्री एलिमेंट्स इन द लास्ट पार्ट, फोर एलिमेंट्स इन द लास्ट पार्ट, फाइव एलिमेंट्स इन द लास्ट पार्ट, सिक्स्थ एलिमेंट in last plus, seven elements in last part. Maximum of all of them will be your answer. Maximum of all these choices will be your answer. Okay guys, so guys, if I go towards the C++ code, the Java and Python will be available very soon. You guys can see that I took N and K, guys. Okay, lovely people. N and K, I took all the B elements in the input. DP and K. So guys, first time cleaning my array. Okay, cleaning my array. Like from let me check. Yeah, doing some cleanup here, guys. Very important to do cleanup. Okay. So cleaning my array. Okay, all things I'm just clearing in my array. Okay, very important to do cleanup these days. There is a slight mistake. I can see that I should have declared a dp and k plus 1. Okay, k plus 1 to avoid the runtime error. Anyways, but it worked. So guys, cleaning my dp array, lovely people. Now I'm going below, and you guys can see one very important thing is that dpi of 1. This I explained to you further only, right? dpi of 1 means divide all the elements from 0 to I in one part, which is nothing but the sum of the numbers till I, multiply that by k. Now guys, I'm going to calculate all the dpij. So I equal to 1 going till n, and j equal to 2. Why j is less than equal to, see, j can only go till k, but then also I put one more limit of I plus 1, क्योंकि कॉमन सेंस है ना. Let's say your I is equal to 5. So 0, 1, 2, 3, 4, 5. You can divide this in maximum 6 parts only. So your j should go from 2, either divided into 2 parts till 6 parts. So j should go from 2, either from 2 till k or from 2 till I plus 1. So whatever is minimum of both of them, I am writing that. So j equal to min of k comma I plus 1 j plus plus. Why this you can calculate, guys. This formula is basically telling you कि current सब array को कौन से number से multiply करना है. So guys, you start taking things from backwards. See, g equal to b of I. You are now trying to take only the last element in the jth array. Slowly your j1 starts including more and more elements in the last part. Okay, so one option is just take the last element. So dpij is nothing but max of dpij, and dpj1 j minus 1, guys. The previous part answer plus the current part answer. Then guys, you keep on g is nothing but the sum of the last part. Your last part keeps on increasing as your j1 is going from I minus 1 to 0. You guys take maximum of that for all those possibilities, and you write your answer, and guys, you get your answer for the test case. Okay, if you talk about the time complexity, lovely people, the time complexity, it will be you can see loop going from 1 to n, then 2 to k, in the worst case I think 2 to k, and then it is again going to from I to 0, right? So n operations here, n here, and k here. So n square k is the time complexity. And let me do a little bit changes in the code. because like it is not giving runtime error, but it will give if we don't fix it. What I should have done is, according to me, I think I should have kept it as a dp and k plus 1, because I'm using k. I'm using going my j is going from 1 to k na, so I should have enough space for that. And the numbers can be negative also na, so let's keep it like this. Minus 1 even a declaration is much better. Okay, so now it feels all right. So dp and k plus 1, I is going from 0 to n minus 1, j is going from 0 to exact k. Yeah, now it seems all right. So let me put that phi 3. I'm trying to divide this array of 5 elements into 3 parts. So guys, you can see this is basic partition db problem. Okay, now there are further many more optimizations which I'm going to tell you, but for now just look at these things. And yeah, good going, nice, awesome. Yeah, so let me replace the code by this one. Okay, so guys, what will be the time and space complexity? Oh, it's a simple time. Let's not only talk about the time complexity for now. It's a n square into k. Okay, n into k into or you can say n square n into k. Okay, something like that. So guys, now this part of problem we have solved it. Okay, now let's change the question. Question is same as above, but now it is not necessary to include all the elements in the subarrays. You are allowed to ignore some elements. So guys, what is the main change did we do in this problem? Now they are saying that, let's say I tell you to divide this array into k equal to 2 parts. Okay, let's say I tell you to divide this array in k equal to 2 parts. Okay, so this is the array given to you, right, lovely people? Earlier when you were dividing it into 2 parts na, it was something like this. You, this is the first part, then second part starts immediately here. But now you can have spaces in middle. Basically you can select any two sub arrays. K equal to 2. Now if someone tells you to divide it into 2 parts, you can say this is my first part, this is my second part, and wherever I'm writing question we are ignoring those guys. So you find any two sub arrays such that their value is coming maximum. So guys, what changes will you make in your DP formula to solve this particular case? It's also very interesting. Very interesting. Same as before, just a small changes needed. You have to divide into k parts, but now you can leave spaces in middle. It's allowed to leave spaces and ignore some elements. So how will you do that? Let's think about it. How will you do that, lovely people? How will you do that? You're Kumar ki student. How will you do that? Leaving some spaces, right? So now guys, dpij will be what? Same as before, but leaving spaces is allowed. Leaving spaces is allowed. Okay, leaving spaces is now allowed. Okay, so guys, let's first try to find out dpi1. Okay, okay, let's first try make a p like dpi1. What will be dpi1? 0 1 2 3 4 5 6 7 8 9 and like that. Dp of phi of 1 basically means that consider the elements from index 0 to 5 and select any one subarray which is having the maximum sum, because you have to divide into one part now, so you can select any subarray like this. And if 1 plus 2 plus 3 is correct, then dp of 5 plus 5 of 1 can be first element plus second element plus third element. So guys, let's forget the actual formula. Let's think about how to find dpi of 1. So guys, you can create a p array. Okay, p array. Okay, okay, like if I try to show you this thing, let me just check if it's all right. Let's check if it's all right. Okay. Okay, so guys, let's create a p array. P array should tell you the maximum sum subarray ending at that particular index. Okay. This is the array B given to you, index 0, 1, 2, 3, 4, 5, 6, 7, 8. Now if I create a P array, guys, what is the maximum sum ending at the index 0? 2. What is the maximum sum subarray ending at this index? It is 3 plus 2, 5. What is the maximum sum subarray ending at index this? Is it 2 plus 3 plus 4? 3 plus 4, 7, 8, 9. Okay. So basically at each index, you just try to find out what is the maximum, maximum sum you can get. So guys, if you want to find the maximum sum you can get where the subarray is ending at this index minus 100, then the answer will be minus 100 plus 3 plus 4 plus 2, which is 9, minus 100 plus 9. So minus 91 it will be, right? Minus 91 it will be. It's not good, but that's the truth. It will be minus 91, the best answer, such that, yeah, the best answer, such that the subarray is ending at index 3. Okay. So minus 100 plus 9, so minus 91. Guys, here there are two options. Which is the best subarray which is ending at index 4? It is the 2 itself. Don't join this 2 with minus 100, then it will become a very big negative number, minus 98, things like that. No. So you totally ignore this part. The best subarray ending at index 4 is 2 itself. The best subarray ending at index 5 is 2 and 5. And for index 5, it is 2 and 5, 7. For index 6, it is 8, 5, 2, like this. So I hope you guys got it how to create this P array. So in our code, for the second problem, we can see that we are creating this P array. Okay. Yeah, let me check. Where did it go? Yeah, this P array, guys. So P of I is what? It is either the current number or the best sum till previous index plus current number. Either the current number or P of I minus 1, the best sum till previous index ending plus the current number. So when I came at 2, I had two options. Either just take 2 or take 2 plus best answer till this, which is minus 91, P of I minus 1. So minus 2 plus 91 is still minus 89, and only 2 is much better. So I took only 2. That's why I hope you guys understood what is P of I. P of I is telling me at any time. P of I is telling me at any time. P of I is telling me at any time. Uh, Best sum subarray ending at index I. Okay. So guys, what will be DPI of 1 in this case? DPI of 1 will be, in this case, DPI of j same as before, but not including the elements is allowed. Not including the elements is allowed, guys. Okay. So guys, DPI of 1 is nothing but maximum sum subarray which you can get till index I. So you can either run the Kadane's algorithm, or you can just take maximum of all the P of I value. P of 0 will tell you the maximum sum subarray ending at index 0. P of 1 will tell you the maximum sum subarray ending at index 1. So if you take a maximum of all the P values till index I, you will surely find one subarray which is the maximum sum subarray out of these. Basically, if I, let's say in this question only, if I ask you DP4 of 1, DP4 of 1 means max of P0, P1, P2, P3, P4. What is this doing? maximum of these five numbers. So maximum of these five number is 9. 9 is the answer. बेसिकली वो ये बोल रहा है कि 0 से लेके 4 तक जो एरे बना है ना आपका, इसमें से सबसे मैक्सिमम सम सब एरे कौन सा है? मैक्सिमम सम सब एरे 2 3 4 है, जिसका सम 9 यहाँ पर है। तो ये जो पी एरे आप बना रहे हो ना, इसके अंदर 0 से 4 तक जो भी नंबर आए हैं उनका मैक्सिमम ले लो। Why? Because P of 0 tells you the maximum sum sub-array ending at this index. P of 1 tells you maximum sum sub-array ending at this index. P of 2 tells you maximum sum sub-array ending at this index. P of 3 tells you maximum sum sub-array ending at this index. P of 4 tells you maximum sum sub-array ending at this index. If you take the maximum of all, it will give you dp4 of 1. Okay. So guys, you can see in the code also that I'm going from 0 to n. Sum is nothing but maximum of all the previous p of I values. Whatever I get, I multiplied by k, because first sub-array always gets multiplied by k, na? That's why. Now guys, the formula remains exactly the same. You don't have to do any change, lovely people. Ha ha ha. So now this time, you are at your index I, right? So what will be dpi of j? All the same formulas. Either you include this element, last element you include, and whatever is the best answer for the remaining part, dpi minus 1, j minus 1. Or you take the last two elements and then you write dp of I minus 2 and j minus 1. So same formula, same thing. But this time this dpi minus 1 j minus 1 का मतलब मालूम है क्या है? इसका मतलब ये है कि you are dividing the numbers from 0 to I minus 1 into j minus 1 parts, but the spaces are allowed in them also. So it is following the congruency, no problem. But guys, there is one corner case which we are missing. What is that corner case? This time dpi of j is equal to dpi minus 1j. Basically, 0, 1, 2, 3, 4, 5, 6. Let's say you want to find dp5 of 2. So you can say that if you dp5 of 2 can be same as dp4 of 2 also. Why? Let's say to divide the first four, like numbers from 0 to 4, this is the best way. 0 to 1, 2 guy ignore, third and fourth. So dp5 of 2 is nothing but the answer for the first 5 till index 5. So you can ignore this guy and you can say that whatever was the answer till here, that is the best answer. Because this time ignoring is allowed. You can ignore the given number. जैसे लड़की आपके मैसेज इग्नोर करती है व्हाट्सएप फेसबुक में कुछ सालों पहले. So you are allowed to ignore. You are allowed to ignore. So you can ignore the current guy and you can say that whatever is the best answer till the previous number dp4 of 2, whatever is the best answer till dp4 of 2, whatever is the best answer till dp4 of 2, that's what we are going to take. So guys, I hope you understand this mystery. Basically the formula is totally same, no change, but in the last you will add one more line, which is dpij is nothing but max of dpij and dpi minus 1j. Why? क्योंकि जरूरी नहीं है कि करंट एलिमेंट को आप जेथ पार्ट में डालो. यू कैन जस्ट इग्नोर दिस एलिमेंट एंड वॉट एवर वॉज द बेस्ट आंसर टिल द प्रीवियस वन, just take that and you can say that that is also your best answer. Got my point guys? Got my point? I hope you guys understood these things. So guys, so guys, I hope you understood that dp5 of 2 is nothing but dp4 of 2. Okay, you can ignore the current guy. So dpi of j, same formula as before, formula as before, but compare with dp I minus 1 comma j also, because it's allowed to not put b of I in the jth part. So guys, yeah, in this code also little bit changes are needed. Like I will declare this with all the values I will put with minus infinity, because the I want maximum now, that's why. And here you need to write dp n of k plus 1. Okay, so again guys, the same time complexity. Okay, O of n into k. Okay, so guys, now next thing, guys, now we are doing the exact lead code question. Lead code is saying that you have to divide the array into k parts. It's not necessary to include all the elements, but the first part you multiply it with a plus sign, second part you multiply it with a negative sign, third part you again multiply it with positive sign, fourth part you multiply with negative sign, even parts you have to multiply with negative sign. So guys, only one change you have to do. Okay, you just need to change the sign in the previous code. तो जो आपका previous code था ना बच्चों, बच्चों whatever was your previous code ना, you just need to make sure you change the sign. See, if you are trying for even part na, then you do minus g into y, and if it is a odd part you do plus g into y. Basically, even number subarray you have to subtract its sum, and odd number subarray you have to add its sum. Okay, lovely people. Okay, so this is also solved. We just change the sign. Okay, if by putting the j condition, change the sign. Change the sign for even number subarray sum, time complexity n into k. Now guys, the actual lead code problem, we have understood the partition concept. You try to fix the last part, okay, or try to ignore it, okay, and you do this thing, but lead code will not like you to solve this problem in n square k. You have to further optimize it. So guys, how can you do the optimization? I always teach these things to my students. Okay, further optimization, how can you do? Always remember, in dynamic programming now, or in anything in life in general, necessity is the mother of invention. Similarly, adding more dp states is nothing but the necessity. Changing the dp formula is the necessity. So how can you optimize it, guys? You guys can see that again and again two things are happening here, right? What are the two things which are happening? Whenever you are at index I, when you are at index I, you are either either including this element, or you are ignoring this element. So why not make two states, dpij0 and dpij1? Okay, three-dimensional dpij0, same as before, but it is guaranteed that the that the ith element is not included in the jth part. Okay, and what will be its opposite? dp ij1, same as before, but it is guaranteed that the ith part, ith number is included in the jth part. So guys, the thing is that you can see the time we are taking in the problem now. I loop and J loop is totally fine. This extra while loop is creating all the problem because we are checking. हम लोग क्या कर रहे हैं ना? We are checking what will be the answer if we just put a single number in the last part. What will be the answer if we put the last two numbers in the last part? What if will be the answer if we put last three numbers in the last part? What will be the answer if we are taking last four numbers in the last part? Because of this J1 loop is going from here till zeroth index. Okay, so we need to eliminate this. We need to do find the best answer in just over one time. Okay, and there is one more possibility. What if we ignore that? So ignore को मैंने अलग ही कर दिया. So guys, this time dpij0 you have to find out. What will be the best answer to divide the first I elements into j parts such that the last element is ignored? So guys, this is so easy, right? Nothing is there in this. Let's say, so easy. You are at this ith index. You want to find dp I of j of 0. So simple. You have to ignore this, right? You have to ignore this. So whatever is the best answer to divide the I minus 1 elements, that will be your this answer. You have to ignore this anyways. So dp I minus 1, whatever is the best answer to divide the previous I minus 1 guys in j parts such that this guy is included in that, or dp of I minus 1 j such that that guy is not included. Take both the possibilities. Max of both of them will be your answer. बेसिकली dpij0 मतलब क्या? dpij0 मतलब बेस्ट आंसर आपके क्वेश्चन का सच दैट दिस लास्ट नंबर इज नॉट इंक्लूडेड. So if this last number is not included, then the answer is nothing but the best answer for 0 to I minus 1. So best answer for 0 to I minus 1 is dp I minus 1j, dp I minus 1j. पर एक बार मैंने लिखा है dp I minus 1j1 और dp I minus 1j0. Why? अब इसमें भी तो दो ऑप्शन हो सकते हैं. Here also there can be two options ना. You can divide 0 to I minus 1 in j parts such that the last number is not included or the last number may be included. So you check both the possibilities and write in the formula. So if you open and check the code, same things are going on. Nothing special. Nothing special. Nothing special. Nothing special. See here. See here, guys. Let's take the odd. See, I is going from 1 to n, j is again going. This time the j1 loop is not there, okay, because you have separated the states. So guys, what is dpij0? Simple. What is the way to divide the first I element into j parts such that the last number is not included? If you don't want to include the last number, the answer is the best answer to divide the first I minus 1 elements into j part such that the I minus 1th guy is included in the jth part, or even the I minus 1 guy is ignored. Okay, so you take maximum of both of them. But guys, this is a little tough nut to crack. dpij1. dpij1. Ha ha ha. I will show you the essence of this is the main thing. अब आप इंडेक्स आई पर हो. You want to divide this into j parts. Okay, now guys, you have two options. You have to include this I in your jth part, huh? One means you have to include this ith element in your last jth part. You have to include it. So guys, what you can do, one option is you include this single element in your jth subarray, and rest of all the elements from 0 to I minus 1 you divide them into j minus 1 parts. Okay, so you can see the formula. If you just take a single number, if you just take the single number in the, like, include the single number in the jth part. If you include the single number in the jth part, so this single number you will multiply it by y. That this formula I have seen before only. Basically last का सिर्फ एक ही number include कर रहा हूं मैं. दो तीन चार में तो ignore कर दो. Last का only one number I included in the jth part, and whatever is the best answer for dp I minus 1 j minus 1. So b of I into y, b of I into y, where it did it go? Yeah, guys, see here, b of I into y plus the best answer for I minus 1, j minus 1. But guys, here also I have to write I minus 1, j minus 1, 0, I minus 1, j minus 1, 1. क्योंकि अभी दो दो स्टेट है ना, दोनों को लिखना पड़ेगा. Got it, guys? If you try to include the last number, so there are two options. Just include this last number in your jth part. Include this last number in your jth part. अगर इसको j में डाल रहे हो तो लास्ट जो नंबर है उसको y से मल्टीप्लाई करोगे ना. दिस इज योर jth सब एरे. दिस इज j number sub array. J number sub array. And in this sub array there is only one element. Only one element is there. इसको डाल दिया और बाकी सबको तुमने डिवाइड कर लिया द डिफरेंट j minus 1 सब एरे. सो dp I minus 1, j minus 1, 0 also, 1 also. Guys, what is the another option? देखो, in this formula ना, you guys have understood the first part of the formula, which is putting the last element in the jth sub array. So guys, you can put the last element in the jth sub array. So last element you put in the j sub array, b of I into y, plus solve for the rest of the part, which is dp I minus 1, j minus 1, 0 as well as 1. You will take both of them, okay? dp I minus 1, j minus 1, 0, dp I minus 1, j minus 1, okay? The next is either you put the last two elements in your jth sub array, or you put last three elements, last four elements, last five elements. But अगर ये सारा चेक करने जाओगे तो टाइम कॉम्प्लेक्सिटी इश्यू हो जाएगा ना बाबा जी. So now guys, there is a secret trick. Like, this is the essence of this problem which no one wanted to explain you. देखो, this is index I. You want to know dp ij1. Basically divide the first I elements into j parts such that the ith element is included. So if the ith element is included, let me assume that this is included in the jth sub array, and then rest all the part is different. So the answer will be dp of I minus 1, j minus 1. So dividing the 0 to I minus 1 elements in j minus 1 parts, plus this is in the jth sub array, na, only one element in the jth sub array, so b of I into y. Y is a constant, we will find it out. But guys, अब दूसरे ऑप्शन को कैसे चेक करोगे? Like putting last two elements in the jth sub array, putting last three elements in the jth sub array, 4, 5, 6, 7. The trick is that you have already pre-calculated this in your dynamic programming. Basically, lovely people, dp I minus 1j has already calculated the best answer. Let's say this is your index I, okay? Okay. This is I minus 1, okay? Okay. Okay. Let's say dp I minus 1, 3 visually was this. You include this subarray, you include this subarray, and you include last these three elements. Okay, guys, please imagine it. dp I minus 1, 3 means selecting those red parts. First part, second part, third part. Okay. So you select those three parts. First part, second part, third part. So guys, what will be dpi of 3? dpi of 3. One option is very simple. What is the one option? One option is that you put this guy in your third part, right? You put only this guy in your third part, right? You put only this guy in your third part, or you put these two elements in your third part, guys. Now you can put either these two elements in your third part, or you can put these three elements in your third part, or you can put these four elements in your third part. So what you can do is you can just write b of I multiplied by y, okay? This number multiplied by y, and these are already multiplied by y, okay? Plus dp I minus 1, 3. जो जे यहाँ पर रखा है वो यहाँ पर भी रख लो. Basically, dp I3 is nothing but b of I multiplied by y इसको तो y से मल्टीप्लाई करना ही है, पर प्लस वॉट एवर वॉज द बेस्ट आंसर such that the I minus 1 guys were divided into three parts, and I minus 1 is surely included. If I minus 1 is surely included, then when you add a I, then I minus 1 and I both will surely be included. मतलब लास्ट के दो एलिमेंट्स पक्का अंदर होंगे. एंड बिकॉज DPI माइनस वन, ये जो DPI माइनस वन थ्री है ना, इसने एग्जैक्टली स्टोर करके रखा था. इसने क्या एग्जैक्टली स्टोर करके रखा था? इसने DPI माइनस वन थ्री कॉमा वन, वन लिखना तो मैं भूल ही गया हूँ, ठीक है. DPI माइनस थ्री कॉमा वन, मतलब लास्ट का I माइनस वन तो इंक्लूड होगा ही होगा. सो DPI माइनस थ्री कॉमा वन, I minus 1. So if I like write create a red color here, first sub array, okay, and let's say this is the second sub array, okay. So DP I minus 1, you divide it into two parts such that the I minus 1 guy is included. You let's say know this. This is nothing but the red color part, okay. So what will be DPI of 2 such that ith guy is included? This is nothing but same as above. DPI minus 1 to 1 plus B of I into Y. This is the ith element. So guys, what is the best way to divide from 0 to I such that they are divided in two parts and the ith element is included? Abhi aapko, you want to include ith element also, na? So this I element you include and you join this I element with this second jth part. पहले वो जुड़ नहीं रहा था, पहले वो earlier this was jth part and the thing from I minus 1 was j minus 1 part. This time I minus 1 ending is also jth part only. So these two elements, sum has been multiplied by y only. Now you are joining this guy with this guy, which is turning, which is making the second part as the last three elements. Till I minus 1, the second part had two elements. Now for the ith guy, the second part has three elements. So you don't even need to check how many elements to take. If you directly use the state of dpi minus 2, 1. So guys, formula. DPIJ1, वन ऑप्शन तो मैंने आपको दिखा दिया. इफ यू आर इंक्लूडिंग टू और मोर देन टू elements in the end at the index I, then the answer is nothing but whatever was the best answer till the previous index, but for the same number of parts, because now you are adding your current number to the same jth part of the previous index. So समझो 5 एलिमेंट है, उनको आपने दो पार्ट में डिवाइड किया सच दैट जो दूसरा पार्ट जो है ना वो लास्ट को टच हो रहा है. इट इज नथिंग बट वॉट एवर यू डिड फॉर द फर्स्ट फोर एलिमेंट सच दैट द fourth element is in the second part for sure, okay. Plus the current guy. Current guy is the new guy getting added to the jth part multiplied by y. So this is another option. So guys, the same option has been. Writing this single formula, consider all the parts. It consider all the six scenarios, like last two elements in the jth part, last three elements in the jth part, last fourth elements, five elements, six, सारे consider हो जाते हैं ये formula से, because it was pre-stored. So one option is this, तो you already saw na. Take the current element separately in the jth part and rest of all the elements in the j minus 1 part, 0 to j minus 1. Or take the current element in the jth part and take some of the elements of the previous stuff also in the jth part only. So dpi minus 1 j1, dpi minus 1 j1 plus v of I into y. And guys, this eliminates. This is Such a brilliant observation. If you understand this partition and DP optimization, you will just be so freaking strong in DP. So, guys, that's it. And this eliminates the loop and it's O of n into k, and this solves the problem. All the codes, relevant ones, will be uploaded very, very soon. So, hope you guys enjoyed the session. Sorry for the long session. Okay. Love you all, guys. Take care. Good night. Ram Ram. Love you all.